From the genetic evolution of our food crops to our own. If we look at the path of human evolution, it's generally assumed that our genes developed from earlier primate forms through mutation. Largely accidental changes which gave one individual an advantage over another, for example, being able to run faster or see further, which then aided their chances of surviving and reproducing, and so spreading those genes. However, once we became human and developed societies and culture, new forces were at play. And that's the theme of a new paper, one of the authors of which is Matt Ridley, a science writer with a keen interest in what makes us human. And in it, the authors say that culture may be driving genetic changes rather than the other way around. Matt Ridley joins us now. Matt, first of all, tell us, what's the full picture here? What made you think like this? Are there specific examples you can give where cultural change has driven genetic change?
Yes, we actually know quite well now that of some good examples where cultural change came first and genetic change followed. So, for example, the ability to digest milk as an adult is something that Western Europeans have, and that's because we started rearing cattle and drinking their milk, and so adults got indigestion because they couldn't digest the lactose in the milk, but the gene for being able to do so, which is switched on in infants, stayed switched on in the odd person, and that person therefore had an advantage, didn't feel quite as unwell, was healthier, got more marriage offers, something like that, and ended up therefore spreading his genes faster. So the genetic change followed from the cultural invention. And our argument is that there are lots of other examples of this, and they probably go rather further back in time than we've been thinking.
Isn't it possible that it happened the other way around, though, that the genetic mutation that led to a tolerance to milk led to dairy farming and therefore was the driver of that culture?
Well, we think that's unlikely because if you look at where dairy farming happened, it happened in East Africa and it happened in Western Europe. It's really quite implausible that somebody woke up one day saying, I'm an adult and I can still digest milk. I don't know how I know that, but I do know that, and therefore I'm going to go out and domesticate cattle. It's more likely that it's in an environment where you're already trying to digest milk. But by the way, you get a lot of goodness out of milk, whether you don't. It's not just the lactose. There's other good things in milk, but you can get even more benefit from milk if you've got this gene switched on. So it's more likely that the mutation, which probably occurred every now and then anyway, was only at an advantage in a population that was already drinking milk. And we make the same argument about language, that some of these genetic changes we've identified in human beings for facilitating spoken language would only really have been much use in a creature that was already doing vocal communication.
I mean, that has got to be one of our largest cultural differences between humans and other animals. What could have driven the development of that?
Well, imagine that there's a group of apes somewhere in Africa, and they do what all apes do, which is they just sort of express themselves with shrieks and groans a bit, but there's nothing very dramatic about it. And one group, rather than another, begins trying to just sort of by accident almost, trying to communicate slightly more precisely using their voices, using the noises they make instead of using gestures, say. Maybe because they're living in a dense vegetation so they can't see each other or something. And it's almost a conscious thing to start with. Let's do the sort of screaming rather more precisely. Let's try and get more nuance into it. If a creature is then born that happens to be really good at this rather precise squeaking and groaning, then it'll do better in the environment. It'll be able to express itself better, it'll be able to understand better, and maybe it'll have more offspring. And so the whole process would get started.
So it sounds fairly plausible, but not everybody would agree.
No, indeed. And our paper, Simon and my paper, has produced some responses where people say, hang on a minute, you need a brain, you need consciousness, you need all these kind of things before you can even start to talk about culture leading the genes. And we're certainly not saying that in every case culture, if you go right back to the primeval ooze, that culture was driving genetic change then. Of course not. But funnily enough, Richard Wrang of Harvard University has already made a sort of argument like this about what happened probably 2 million years ago, which was with the invention of cooking, where once we started cooking our food, we effectively did a lot of external digestion, so we didn't need such a big gut, so we could therefore afford to grow a big brain. And he says that the invention of cooking allowed the species to suddenly increase the size of its brain. And we're talking about a predecessor to Homo sapiens there. We're talking about Homo erectus or something like that.